Hi, my name is Mario Kasahara. I'm an application engineer for MEMS mirrors. Today, we'd like to show you how to operate 2D scanning MEMS mirror with its dedicated driver and software. By the end of this video, you will learn how to set up the hardware, how to set up the application software, and how to operate a 2D scanning mirror. As you go along, you will also learn what kind of technique is needed to operate a 2D scanning mirror. First, we'll show you how to set up the hardware. These are the hardware you will need. First, MEMS mirror S13989-01H, driver board C13884HC, and 3 kinds of cables: power cable, USB cable, and the mirror and driver connection cable, and 1 connection cable to the mirror. Another thing you will need is a low voltage power supply and PC with USB interface. Also, it would be nice to have some kind of optical setup to reflect the laser beam onto the projection screen so that you can see the mirror movement. Now, later we will show you the video demonstration. For that demonstration, we used the laser Edmond model number 57-105. There are cautions you must be aware of in setting up the hardware. Keep away from magnetic material. Keep away from other MEMS mirrors. MEMS mirror magnet is very strong, so please be careful not to put metal object near the mirror. For example, if you have metal screws, they will be attracted to the mirror. Also, if you have another mirror or any magnetic object nearby, they will crash into each other. Next, we'll show you how to install the application software for C13884HC. Before installing, please make sure that USB cable is not connected to the PC. Now, the content of downloaded folders look like this. First, install the USB driver from the CD that came in the kit or download from the link we provided. Find the file driver setup 32 or 64-bit exe in the driver folder. Open the one that matches with the OS and follow the installation wizard. We have confirmed the compatibility with Windows 10. Next, install Application Setup exe in the application folder and follow the installation wizard. When installation is successfully completed, the icon shown here will appear on the desktop. Next, let's prepare the hardwares. First, you can connect the driver board to MEMS mirror through this color cable and a flex cable connector. Also, this driver board is connected to the PC USB port. And finally, this driver board connects to the low voltage power supply. Now, we're ready to apply the 5 volts to the driver board. Now, we're ready to start the application software. Now, we'll explain the basic functions of the application software. On the left side is the waveform setting screen. Right side is the parameters setting screen. Upper right section is for the nonlinear or resonant axis, and lower right section is for the linear axis. First, you need to establish the communication between the driver board and the application software. Go to File, Connect. When the connection is successful, the Set Parameters section on the right will be activated. Check the All Set function on so that the application software will reflect the parameter changes automatically. Let's start operating the nonlinear axis or resonant axis. We're going to use the upper right section of the controller screen. This section controls a nonlinear axis, also known as resonant axis or fast axis, which many people use as the horizontal x-axis of raster scanning. For this axis, the mirror oscillates at the resonant frequency of the mirror. First, check the mode is closed and the flip horizontal is off. Next, change the current value to 20 milliamps. Then set division ratio mode to auto. Then turn the control to on. Wait for about 10 seconds while the software sweeps the driving frequency of the mirror. When it matches with the resonant frequency, the mirror starts moving back and forth, and you will see that the laser spot becomes a scanned line. You can adjust the mirror's maximum tilt angle by changing the current value in the nonlinear axis mirror section. Before moving to the linear axis, please turn off the nonlinear axis by turning the control button to off. Now, let's operate the linear axis. The lower right section is for the linear axis control. The linear axis is also known as slow axis, which many people use as vertical y-axis of raster scanning. On the linear axis, the mirror tilts at any desired angle. Let's try static mode first. Set mode to static mode and flip vertical to off. Then set control to on. As you move the slider to the right, the mirror moves vertically, proportional to the drive current. When you finish the operation, turn control to off. Now, let's try linear axis dynamic mode. Set mode to dynamic mode. Then flip vertical to off. Next, set the frequency to the minimum frequency by moving the slider to the furthest right position. Next, set the waveform. Select the waveform from the left button's Select Pattern section. This time, we will use sine waveform. Next, set the peak value. This time, we will set a maximum value of 1300 on top and a minimum value of negative 1300 on bottom. Then click the Set button. Click OK on the pop-up window. Then the linear axis will automatically turn on. You can adjust the frequency in the frequency section. Moving the slider to the left makes the mirror move faster, and moving it to the right slows it down. When you finish the operation, turn control to off. Next, let's try raster scan. First, in the nonlinear mirror section, check the mode is set to closed and division ratio mode is set to auto. For the linear mirror section, set the mode to dynamic. We're going to use the same sine waveform setting. From this setting, first click the large Set button below the waveform display window. Click OK on the pop-up window. Wait for about 10 seconds. First, you will see the nonlinear axis begin to move. Then, the linear axis begins to move. You can change the frequency of the linear axis. Moving the slider to the left makes the mirror move faster, and moving it to the right slows it down. Also, you can change the nonlinear axis tilt angle. Move the current slider to the left to make the angle narrower and to the right to make it wider. When you finish the operation, turn control to off. I hope you found this video to be helpful in operating Hamamatsu 2D scanning MEMS mirror. Hamamatsu 2D scanning MEMS mirror features about 30 kHz of resonant frequency access. Also, it comes in durable ruggedized package available in production volume. We also can build custom module. We can build a light source, optics, detector, and a driver inlet. Please consult our sales representative for further assistance. There is another podcast entitled, Is MEMS Mirror a Good Fit for You? In that video, we explained Hamamatsu MEMS mirror lineups, MEMS mirror technology comparison, and applications. Please check out for that video also on Hamamatsu YouTube channel.